creative way result.
Apologies.
This is Bassador creative problem solving model. I centered my research on the Bassador creative problem solving model, which consists of 8 steps: problem finding, fact finding, problem definition, idea finding, evaluation and selection, plan, acceptance, and action. Each step includes and requires both divergent and convergent thinking skills. Divergent thinking helps generate multiple creative ideas, while convergent thinking refines and selects best solution. So, how to solve this problem? Actually, this question should be, what do you see? What is the problem in this picture? Some may say the cat is waiting to be rescued, while others might focus on the man, perhaps he is in need of help, or other problems. The key takeaway here.
I'm sorry, I'm not seeing your pictures. I'm just seeing the slide. Your first slide. Sorry to interrupt.
Dan, can you see my slide presentation?
We see your title slide.
Title slide, yeah.
I know you were sharing it earlier, so I'm not sure why it didn't change on screen.
No, I'm not. Why didn't it change? But no, it's the same.
It is the same.
Now?
Maybe you could stop sharing and then reshare.
Okay.
That just works.
Sure. I'm going to stop the sharing and sharing again.
There we go. We're seeing a diverge, converge.
And simplex creative problem solving model.
Yes.
Okay. I start the slides. This is Bassador creative problem solving model, which consists of 8 steps: problem finding, fact finding, problem definition, and all the action steps. Each step includes and requires both divergent and convergent thinking skills. Divergent thinking helps generates multiple creative ideas, while convergent thinking refines and selects best solution. I centered my research on the Bassador creative problem solving model. I use this model in my research. And now, I assume, can you see the this picture, right?
We see the model still.
No.
It's still the same picture. This is strange because when we were rehearsing, all the slides were changing.
Yes. Wow. It's interesting. It's strange to me.
Yes, it is.
I'm changing the slides. And I'm gonna stop again. And vice turn. And I'm going to share my screen.
Okay, that's the title slide. And there we go. There's the photo.
Perfect. Finally. Sorry for the interruption. How to solve this problem? Actually, this question should be, what do you see? What is the problem in this picture? Probably, some may say the cat is waiting to be rescued, while others might focus on the man. Perhaps he's in need of help or another problem. The key takeaway here is that different people perceive different problems, And because we have diverse problems, we must generate diverse solutions. This is the essence of creative problem solving. Instead of looking at a situation with just one answer, we explore multiple perspectives. We think divergently to generate as many ideas as possible. And then we apply convergent thinking to select the best solution for our problem. The 4Ps of creativity framework is understanding different dimensions of creative thinking and innovation. This research focuses on the elements of person and process. The person dimension in creativity research includes cognitive traits, skills, expertise, and background experiences that individuals bring to the problem-solving process. Disciplinary background shapes cognitive styles, problem-solving approaches, and domain-specific knowledge. For example, engineers may focus on analytical and systematic solutions. Artists may employ more divergent and abstract thinking. For process, CPS relies on both divergent and convergent thinking. Homogeneous teams may have a shared mental model but lack diverse perspectives. Heterogeneous teams may enhance the CPS process by bringing multiple cognitive styles. Basadur's problem-solving model, known as the simplex process, identifies 4 different approaches that people may use when tackling problems: generator, conceptualizer, optimizer, and implementer. People who are generators say, I've got some new ideas we can start on right now. Or people who are conceptualizers say, let's understand the big picture first. People who are optimizers say, we need to make a plan. We can just do whatever we want. And people who are implementers say, enough theory. Let's get out there and get it done. So, what is interdisciplinary? It involves focusing on a specific field or subject, exploring deeply, and often collaborating with others within the same or close discipline. On the other hand, cross-disciplinary, this approach involves sharing knowledge and method across disciplines, allowing for a more integrated and interconnected understanding of a problem. This study examines the impact of disciplinary composition on creative problem-solving performance among honors college students enrolled in the creative problem-solving and innovation course at Western Kentucky University. A case study approach was employed, integrating qualitative and quantitative data. Quantitative data was collected from students' CPS projects, which measured their divergent and convergent thinking skills. Qualitative data was obtained through student interviews. 12 honors college students representing a range of academic disciplines participated in this study during the fall 2023. The participants, identified as S1 through S12, were derived from the following majors: biology, design, chemistry, human resources, business, and performing arts. The teams were composed as shown in the figures. For instance, biology and chemistry form an interdisciplinary team, and chemistry, business, and design form the cross-disciplinary team. This is outline of the course. Participants engage with tools for both divergent and convergent thinking and explored creative problem-solving styles, recognizing that each individual has a unique approach to solving problems. Following this, we assigned them CPS projects spanning 4 weeks, allowing them to apply their knowledge in real-world scenarios. They collaborated with students from different majors, working in turns throughout the week. Each week, they switch peers, continued this process for 4 weeks. Data analysis. We measure students' divergent thinking scores using creativity quotient formula. This is logarithmic formula. Creativity is typically evaluated through fluency, flexibility, and originality. Given that 12 students participated, all responses were expected to have high originality scores, meaning that fluency would naturally elevate originality scores. Therefore, the CQ score was utilized instead of relying solely on originality. And due to the small sample size, divergent thinking scores were normalized to a 5-point Likert scale to ensure compatibility with convergent thinking ratings and facilitate statistical analysis. Man-with-EU tests compare the divergent thinking and convergent thinking scores between cross-disciplinary and interdisciplinary teams. This is divergent thinking rubric and convergent thinking rubrics here. Integrated reliability was established by having 2 independent researchers score the rubrics and calculate agreement scores. The integrated agreement was 94%, which shows an almost perfect agreement between 2 raters. Qualitative data analysis, semi-structured interviews were conducted with students to explore their experiences working in cross and interdisciplinary teams. And then thematic analysis was applied to identify pattern and recurring themes related to team dynamics. All interviews were imported into MaxQDA for processing. And here's our results. We measured divergent and convergent thinking at each step. On the left, we have 8 steps of CPS. We compared 2 team composition for each step, cross and interdisciplinary team. Overall, cross-disciplinary teams score higher in divergent thinking across all CPS stages, whereas interdisciplinary teams perform better in convergent thinking at every stage. As shown in the table, the creative problem-solving scores differs between cross-disciplinary and interdisciplinary teams in terms of divergent thinking and convergent thinking across the steps. This figure visually represents the same results, actually, highlighting the trend that cross-disciplinary teams consistently excel in DT, divergent thinking. Interdisciplinary teams perform better in convergent thinking. So we compare the divergent thinking, convergent thinking, and what about general CPS performance? Overall, the CPS scores are so similar. When we look at the Man-with-EU test results, the statistical analysis reveals that for divergent thinking, the cross teams significantly outperform the intra team. For convergent thinking, intra teams significantly outperform the cross team. But in general CPS, there is no significant difference between the cross and interdisciplinary teams. The results suggest that cross-disciplinary teams excel in divergent thinking, generating a wider range of ideas, and however, interdisciplinary teams show stronger convergent thinking, meaning they are better at evaluating and executing ideas efficiently. Also, these results indicate that CPS effectiveness depends on the balance between divergent and convergent thinking. A hybrid approach where teams integrate diverse perspectives for ideation and specialized expertise for execution may optimize CPS outcomes. As for the qualitative results, thematic analysis identified 4 themes. Theme 1, cross-disciplinary diversity boosts ideation. Participants highlighted cross-disciplinary teams' power in CPS driven by diverse perspectives, creativity, complementary skills, and a broader knowledge base. For instance, one participant emphasized each member has different interests, knowledge, and ways of thinking. Another participants, each member is able to contribute unique ideas based on their unique characteristics. These different interests, knowledge, and ways of thinking allow teams to see a problem from multiple angles and generate multiple solutions. Theme 2, interdisciplinary homogeneity facilitates convergent thinking. Interdisciplinary teams demonstrated greater efficiency in convergent thinking. And one participant highlighted this efficiency. With interdisciplinary groups, most of us thought in similar ways and agreed on most ideas. Several participants also noted that interdisciplinary teams reach conclusions faster than other teams. Theme 3, disciplinary background influences CPS role. Participants highlighted that their field of study strongly influences their approach to problem solving, shaping their cognitive strategies and decision-making processes. One participant noted, my major has taught me a little bit about tackling creative challenges, but the amount of creativity you can use in accounting is limited. Participants recognized skill transferability as some problem-solving strategies learned in their major could be applied in broader contexts. For instance, some problem-solving strategies I have learned in my major have been useful in multiple settings. Theme 4, heterogeneous teams face collaborative hurdles. Cross-disciplinary collaboration encountered barriers. Several participants mentioned difficulties in understanding field-specific terminology. A few noted that team members sometimes struggle to accept alternative viewpoints. For instance, some participants said more disagreements, getting on the same page. It is extremely difficult to understand someone's points of view if they think in a totally different way I do.
So just so you know, we have about 1 minute.
Okay. Overall, working in a team, whether cross-disciplinary or interdisciplinary, has both advantages and disadvantages. So, what does this mean for real-world problem solving? Disciplinary composition significantly impacts the CPS performance. One of the most critical insights from this research is that social emotional skills play a crucial role in supporting CPS performance. In today's world, creative problem solving is essential. This study confirms that while disciplinary diversity sparks innovation, expertise refines and implements solutions. Creativity is not just about thinking differently. It's about knowing when to integrate diverse ideas and when to streamline execution. Thank you for listening to me. Thank you for your time.
Yes, thank you so much. I'm so sorry we lost a few minutes with some of the challenges. However, is there a way that they can follow up with you later with a question if we don't have time to entertain too many right now?
Sure. Yeah, sure. Also, you can also provide feedback on my session to help improve future ones. And you can reach out to me via email or X or LinkedIn. Just scan QR code.
Beautiful. Thank you so much. I'm sorry, I'm not going to be able to allow time for questions today because I have to move on to the next session in a timely manner. But I do want to invite everyone at 2 p.m. to go to the State of the Center for Applied Imagination. Actually, I believe that's now. So is that, Roger, is that 2:15 or
It's 2:15, Pam. Yeah, 2:15 to
All right,
2:45.
thank you.
Yeah. Have a little time.
Perfect.
Yeah,
Yes, you
thanks,
have a little time. So encourage you all to do that. Tomorrow we have another fantastic day following pretty much the same format. So we hope you will return to see us all again. And again, thank you so much for coming. Dr. Akdeniz, thank you so much for this fantastic presentation. And I look forward to going back and reviewing again and seeing your slides.
Thank you. Thank you for this opportunity.
Thank you, everyone. You guys have a great day. Dr. Akdeniz, I will follow up with you. I am going to have to sign off. I apologize.